If you're looking for an autoscaler solution based on events and understand precisely how the autoscaling is behaving, then this episode is for you. Welcome to Is It Observable? The main objective of Is It Observable is to provide tutorials on how to observe a given technology. Today's episode is part of the Kubernetes series where we already covered several topics. We saw how to collect metrics from your cluster, how to collect logs using fluentd, fluentbit, Stanza, how to observe your Ingest controllers, how to optimize your cluster, and what is an autoscaler. Today, this episode will focus on how to autoscale our workload based on external events. We will take advantage of this episode to introduce an amazing CNCF project. I'm referring to Keda. If you enjoyed today's content, don't forget to like and subscribe to the channel. So let's see what you're going to learn out of this episode. We will start with an introduction, then we will look at what is Keda, and we will describe the various CRDs provided by Keda. We will look at two distinct scalars, the Prometheus and the metric API. We will explain how we could collect metrics and events from Keda, and we will do a small interview with one of the maintainers of the Keda project, Zbyněk Roubalík. And last, like usual, we will jump into a tutorial. Like explained in our previous episode on how to autoscale, Kubernetes allows us to autoscale in various ways. In a horizontal way with the help of horizontal pod autoscaler, so HPA. In a vertical way with the help of vertical pod autoscalers, and we're also able to autoscale from a node perspective. All the autoscaling solutions supports only standard Kubernetes objects, so deployments, stateful sets, and replica sets. And also it relies on the metric server. Therefore, if you want to build an autoscaling rule based on custom metrics, you need to use the metric adapter compatible with our data source. If you have no metric adapter available, then you will be stuck with simple resource metrics, which is CPU and memory. The other disadvantage of the standard autoscaling solutions is the way of observing it and collecting how it behaves. So we need to come up with our own sets of KPI to see if the autoscaling is doing the right job. But HPA and VPA doesn't provide metrics by default. So if you, for some obscure reason, our HPA and VPA is not working as expected, then we don't have the data to understand precisely, and we won't have any alerts. Well, with all those challenges, well, I have a good news. There is a CNCF project that will basically simplify the autoscaling process and provides all the data and metrics that we were looking for to get alerted. And I'm referring to Keda. Keda is a CNCF project that will autoscale your workload based on events. And it's an event-driven autoscaler. In fact, Keda stands for Kubernetes Event-Driven Autoscaling. Keda is a lightweight operator for Kubernetes cluster. Keda will manage your autoscaling process by providing the right metric server and the right horizontal pod autoscaler. So how does it work? Keda provides two main roles. There is the agent, so Keda provides an operator that will manage the autoscaling of our Kubernetes objects. You have the metrics. Keda acts as well as a Kubernetes metric server that expose rich event data provided by external solutions with the help of a scaler. With the help of the event, it will drive the horizontal pod autoscaler to scale up, of course, and to scale down. The other advantage is that Keda can scale standard Kubernetes objects like HPA, also deployment, replica sets, and so on, but also any custom CRD. Let's have a look at the architecture. Keda is composed of several components. We have the metric adapter that will behave like a metric server that will be used by the HPA. The Keda operator will interact with the third-party solution to collect the events on the third-party data source with the help of a scaler. And it will report back the metric to the metric adapter. Keda manages the HPA by defining our autoscaling policy through the Keda CRD. The advantage of Keda is that it has a wide range of scalers that can both detect if a deployment should be activated or deactivated and feed custom metrics for a specific event source. So here is the list of the available scalers. So you can see we have ActiveMQ, Artemis, Kafka, CloudWatch, DynamoDB, Google Cloud, Stackdriver, Metric API, Prometheus, MongoDB, and way more. Once Keda is deployed, it will enrich our Kubernetes cluster by adding new CRDs. We have the ScaledObject, the ScaledJob, TriggerAuthentification, a ClusterTriggerAuthentification. The ScaledObject will allow us to manage the autoscaling of Kubernetes objects. So it could be deployments, stateful sets, or any custom CRDs. We have the ScaledJobs. And here, instead of scaling a pod, we will basically scale jobs based on events. So it will basically look at events and trigger jobs that will basically parse that event, act like a batch. You could then figure out the number of jobs based on events. The overall concept of Keda is to collect metrics from an external data source with the help of a scaler, and each scaler have their own way of authenticate to the external data source. In order to mutualize and optimize the authentication process, Keda provides two CRDs for that, so the TriggerAuthentification and the ClusterTriggerAuthentification, which will basically contains the authentication configuration to your external data source. So it could be stored into secrets, vaults, and so on. So we will look at it in more details in a few minutes. The ScaledObject. So here is an example of a ScaledObject. In the Keda ScaledObject, we can find that it's quite similar to the settings that we have in the definition of our HPA, horizontal pod autoscaling. The spec scale target section will hold the reference to the target resource, so deployments, stateful cells, or any other objects of the cluster. We also define the definition of the HPA with the number of minimum replica, the number of maximum replica. Keda provides other settings to manage specific situation. So we have the polling interval that defines the interval to check the metrics. The other great feature is the ability to handle the situation where the scaler is not providing any metrics anymore because it's down or it's saturated. It can be configured with the help of a fallback section. It defines the number of replica to fall back if the scaler is in error state. Keda will keep track on the number of consecutive times each scaler has failed to get the metrics from its source. Once that value passes the failure thresholds, instead of not propagating the metric to the HPA, the scaler will instead return a normalized metric using this formula. Trigger is the section that will define the events that will trigger the autoscaling process. And you will make a reference to usually a TriggerAuthentification object or a ClusterAuthentification object to help you to authenticate Keda to your external data source. One interesting feature of Keda is the ability to pause the autoscaling. This is useful if you have any maintenance operation that you need to deliver on your cluster. So you can pause it by adding an annotation to your ScaledObject. So autoscaling Keda paused replica to 0. The presence of this annotation will pause autoscaling no matter what the number of replica is provided. The above annotation will scale your current workload to 0 replica and pause the autoscaling. You can set the value of a replica for an object to be paused at any arbitrary number. To enable the autoscaling, again, you simply need to remove that annotation. It's in the trigger that we configure the information of our scaler. So here is an example. So here we utilize a metric API scaler. We define a value and then all the rest of the parameters is related to the specific scaler. So here in our case, the metric API scaler. ScaledJob as an alternate to scaling event-driven code as deployment, you can also run and scale your code as Kubernetes jobs. The primary reason to consider this option is to handle processing a long-running execution. Rather than processing multiple events within your batch or your code, for each detected event, a single Kubernetes job is scheduled, and that job will initialize, pull one of the events from the message source, for example, and process the jobs until it completed. For example, if you want to use Keda to run a job for each message coming in a queue, then we can do the firing flow. So when no message are waiting, no jobs are created. When a message arrives in the queue, Keda creates a job. When the job starts running, it pulls one single message and processes it into the final completion. As an addition, new message arrives, additional jobs will be created by Keda. Each job processes one single message from the queue. So here is an example of a scaled job. Scaled jobs offer lots of various settings to define the max duration of a job with activated deadline seconds, the number of retries before failing the job, the event that will trigger the job, the number of parallelism, and so on. It's a great feature, but you will need to define your job to handle only one event at a time. You will then delegate the execution number required for that job by Keda. TriggerAuthentification and ClusterTriggerAuthentification. Most of the scalers that we are going to use will require authentication. So you can manage your credential using secrets or config map, but Keda doesn't allow you to make a reference directly in the definition of your scaled objects or your scaled job. So the only way that you will have is to use a reference to a container information with the environment variable. This is where managing your authentication tokens could turn into a nightmare. It makes it difficult to share authentication between scaled jobs. That is the reason why Keda provides two CRDs to manage our credentials with our scalers, the trigger authentications, and at the cluster level, the cluster trigger authentication. So first you need to define the trigger authentication. So here is the example. And then you can see that there is plenty of various options. And then we need to make a reference to it in our scaled object. The authentication parameters can be pulled out of many sources. So we can refer to environment variables, to secrets, to Hashi Corp vaults, to Azure Key Vaults, pod authentication provider as well. The power of Keda is the large number of scalers. Keda has 50 plus scalers for hyperscale like Amazon, Azure, observability solution like Prometheus, Datadog, and more. and event scalers for ScaledJob scenarios. For our use case, let's have a look at two scalers, the Prometheus one and the metric API. So let's start with the Prometheus scaler. So here is an example of a Prometheus scaler. The definition of the metric is fairly simple. You just need to precise the URL to your Prometheus server and the right prompt URL. If your Prometheus requires to authenticate, you can create a notification through a TriggerAuthentification or a ClusterTriggerAuthentification. Metric API. The Metric API scaler is an amazing plugin. It helps you to connect to any API providing metrics. So here is an example of a Metric API scaler. The Metric API scaler allows you to build the right HTTP API call and extract the value that you're interested using the value location field. In fact, it uses a JSON path. And it also handles several ways of authentication to your API endpoint. So it could be by API key based authentication, it could be basic authentication, it could be a bearer token authentication. Compared to HPA, Keda exposes metrics and events, helping us to understand what is currently happening in our autoscaling mechanism. Events. Keda emits the following event. Here is a list of events. So we have the ScaledObject ready. So every time the object becomes ready, you will have that event. We have the similar one for the job, so the ScaledJob ready as well. We have the ScaledObject check fail. So if the check validating for the ScaledObject fails, then you will have that event. You have the same one for the job. So ScaledJob failed, a check failed. We have the ScaledObject deleted to be aware when a ScaledObject has been deleted. Same thing for the job. We have the Keda scaler started. So when the scaler starts, we will be notified. We have the similar event for the stopped, when the scaler stops. We have the scaler failed, this is an interesting event. When a scaler fails to create or check the event source, you will have that event. We have the scaled target activated. This is really interesting. So it's basically you get an event every time the scaled target scale up to one extra replica, you will have that event thrown. And you have the similar event in the opposite direction to scale down. So the Keda scaled target desactivated. We have the Keda scaled target activated failed. So we were not able to scale up. And we have the same one to scale down. So scaled target desactivated failed. And of course, we have all the events related to the job creation, the object creation, and so on. Based on all of the events, there is lots of events, as you can see, that will be generated by Keda automatically. But it clearly makes sense to focus on a couple of events. So the ScaledObject fails, the scaled target activated, and the scaled target desactivated. So have an event when it's scaled up and having an event to scale down. I think it's great. So we can basically follow everything that happens from a Keda perspective. Keda exposes metrics to the metric server. So at the end, we can query to get those metrics using kubectl. So here's an example. So kubectl gets row, and then we interact with the right API. In our case, it's the API/external metric Kubernetes.io. But we can also query specific metrics. So here we can do the same query, but we add the namespace with the name of a namespace, and so on and so forth. We can also collect metrics from the ScaledObject directly, because Keda updates the ScaledObjects with several information, including the metric. So if you want to recover the metric name, we simply have to do kubectl get ScaledObject and with the right namespace, and then we can do a JSON path to get the external metric name as well. Prometheus metrics. Keda metrics adapter expose automatically Prometheus metrics which can be scrapped. So by default it uses the port 9022, but we can also obviously change that port if required. and the endpoint will be /metrics. The metrics collected in the metric adapter are only active when the HPA is active, so basically when there are more than one replica. The following metrics are being collected and exposed in Prometheus. So we have the Keda metric adapter scale error total, so that's the total number of errors encountered for all the scalars. We also have metrics related to adapter scaled objects errors, so the number of errors that have occurred for each scaled object. We have the Keda metric adapter scalar object, so that's when the scalar has an error. And we have the Keda metrics adapter scalar metric value, so the current value for each scalar metrics that would be used by the HPA in computing the target average. So that's very useful. So we basically, through those values, we can follow as well either the value of that would trigger the autoscaling or any errors related to the Keda's behavior. In order to get the latest news related to Keda, let's call one of the maintainers of the Keda project, Zbyněk Roubalík. Hi Zbyněk, how are you today?
Hello, I'm doing well. I'm great. It's it's summer, it's hot, but I'm doing great. Thank you.
That's true. We are in summer, but depending where you're based, the heat could be perceived completely different. Where I live, it's currently very, very hot. So I'm doing an episode on Keda, and we introduce several concepts like the architecture, the various CRDs, but I would like to take advantage of your presence to ask questions related to Keda project. I think it's really an interesting project that helps the community to implement autoscaling without the need of building their own metric server or metric adapter, and also get the right data. So before we jump to all the questions that I have, could you introduce yourself?
So my name is Zbyněk. I'm based in Brno, Czech Republic. I work at Red Hat at OpenShift serverless team. I'm working on different open source projects, Knative, also Keda. So I'm one of the maintainers of Keda, and we have a small kit, so that's my basically hobby at the moment.
Behind each project, there is always a story explaining why the technology exists. What is the story behind Keda?
Yeah, actually, it's quite interesting. So at the beginning, the project itself started as a cooperation between Microsoft and Red Hat. So people from those two companies joined together and start prototyping around this area. And later we found out, okay, this is something valuable. So we started, to do more. Then the project was open sourced. And later on, it has been donated to CNCF. So now it's like completely vendor neutral project. And basically, we are trying to fill the gap in the space. And I think that we were quite successful in this.
I guess you wanted to bring something that will easily enable the community to autoscaling.
Exactly. That's our main goal. And like the HPA for us, the horizontal pod autoscaler is just the implementation detail. And we really try to make the autoscaling, event-driven autoscaling, that simple, because with HPA, with pure HPA, you can scale based on CPU or memory resources, but that's not enough to cover all the use cases. Because in the event-driven world, sometimes you need to scale, but not based on the actual consumption, but based on some events happening in the external system. So imagine you have a consumer application, for example, Kafka consumer application that consumes messages from Kafka broker, and you would like to scale this application based on the number of unprocessed messages in the Kafka topic. And you cannot achieve this with HPA, or you can, but you need to do all the configuration of custom metrics and all the stuff yourself. So we really try to make this very, very simple.
By studying the various CRDs of Keda, I was impressed by the notion of scaled jobs. That brings a total new use case for our user, trigger jobs based on events. I was wondering if the notion of jobs has appeared after the autoscaling, or was the ScaledJobs one of the main use case of Keda?
At the beginning, we were just trying to solve autoscaling and autoscaling of deployments, Kubernetes deployments. But later we refactored Keda a little bit, the project, and now we can target more resources. So we can target deployment, stateful sets, or basically any custom resources that fulfill some specific conditions. But with this setup, it is awesome to autoscale applications. But if you have some long-running applications that are processing some tasks that take a very long time, it is not suitable to do it with HPA, because basically if you consume the message and you start the processing of the message, the metric that tells us, okay, let's scale out, disappeared because we already consumed the message. But the processing of the message could take several minutes, maybe hours, and HPA could basically scale down the application in the meantime. So that's why we introduced the ScaledJobs to basically fix this problem and to solve this use case.
So I think it's a really clever feature. Do you have any product updates? Anything you would like to share with us related to the Keda project?
So at the moment we have released, or the latest version is Keda 2.7. We have already like a large number of scalers. We have 50 plus scalers. What we would like to improve in the future is basically the core of the project. So one thing is basically to introduce caching. And with caching, I mean that when basically you are scaling your application, when you create a scaled object, you collect the metrics from the external source, for example, from Prometheus or Kafka. But we are just providing those metrics. But if we are able to cache them for some time in Keda, then this would have several benefits. So one benefit could be like the performance-wise. The other benefit could be that basically, if we have these metrics, we can plug some AI ML models and do some prediction on this data, and maybe do some predictive scaling. The other area that we would like to improve is basically observability, and we would like to leverage cloud events. So we would like to use cloud events to collect metrics about Keda itself. Then we have a lot of other like areas that we would like to improve, but I would like to highlight these two.
We have a Dynatrace, an open source project called Captain. Captain relies on cloud events. It's in fact an event-driven orchestration framework. You can do a lot of things, so CI/CD, remediation, SRE automation, and way more. Captain relies a lot on this notion of SLI and SLO. And that brings me to my next question. I would love to be able to implement an SLO-driven autoscaling process. Let's say that we have an SLO in production, and this SLO starts to fail. And we are in a situation where we are fast consuming, so fast burn rate, our error budget. So our system will trigger a remediation to resolve the situation. So we can imagine that one of the remediation solutions is to reach out to Keda to trigger an autoscaling. So the system can send cloud events to Keda and start autoscaling sequence. Is this what you were referring to?
That's interesting topic. What I was mentioning about cloud events is basically the other way around. So Keda exposing cloud events about like what it is doing, like how does the scaling behaves, and what is the number of scaled objects, etc. But this is also a very interesting topic, and I can see the potential there. So basically, we will just implement, let's say, cloud scaler for accepting cloud events, and yeah, I can see a lot of benefits in this area, and yeah, this is completely good. So you are free to implement this one.
I think that the power of Keda is related to the large number of scalers. I know that you don't drive especially the scalers initiative. The scalers are clearly driven by the community, but are you aware of any interesting scalers that the community is trying to build?
You are completely right. So basically, when there is a need for a scaler from community, we encourage users to actually implement the scaler, because the implementation is I would say very simple. You just need to implement specific interface, and then the rest of the stuff is handled by Keda. I'm not sure if there is anything like any like a good scaler to emphasize, but I would like to mention one more thing about scalers. If you are not satisfied with the scalers list that we provide, we have also a concept which is called like the external scaler, which is gRPC interface, and you can implement your own scalar logic in a separate deployment, separate pod, separate container, and you just connect it to the Keda, and this way you can achieve whatever you want internally in your system without even having it in the core. So yeah, I would like to mention this in this aspect.
So if you are looking for a specific data source to autoscale, don't be shy. Reach out to the Keda community. You will get the right support. You can build your own scalers and contribute back to the Keda community. You mentioned observability, and you mentioned the usage of cloud events to expose metrics. But OpenTelemetry is pretty hot in the CNCF ecosystem. In fact, it's the second project in CNCF after Kubernetes. Do you have any plans to provide OpenTelemetry measurements?
Absolutely. That's a great point. I should mention it before, but yeah, we are also looking into this area, and we are looking into this area from both aspects. So like exposing metrics from Keda, but also to provide a scaler based on metrics from OpenTelemetry. So definitely, yeah, we would love to have this very soon. So I would like to follow up on your previous ask to users and community. Don't be shy and just contribute.
So thanks a lot for your time. Thanks for bringing Keda to the community, and that helps and resolve all the challenges that I mentioned. And thanks for taking the time to sharing some project updates with us. So have a great day. See you. Bye.
Thank you very much. See you. Bye.
In this tutorial, we will showcase the usage of Keda to autoscale our demo application based on Dynatrace metrics. For that, we will have several requirements. We will need a Kubernetes cluster, of course, Keda deployed in that cluster, and a Dynatrace tenant. So in this tutorial, we will deploy the nginx ingress controller, the hipster shop like usual. Keda will be also deployed. We will use a metric API scaler. So we will configure Dynatrace to collect metrics, and we will build the right metric expression and also the right query to the Dynatrace API to collect it. We will configure the ScaledObject using the scalar API metric. We will deploy a load test using K6 to generate a node and help us to autoscale and observe the scaling events and metrics from a Keda perspective.
Like every tutorials of Is It Observable, you will find a GitHub repository related to this tutorial. So here we're looking at obviously the one related to Keda. So like usual, I'm not going through all the steps to help you deploy the environment itself. We're going to focus more on the Keda side of the tutorial. So make sure to have a cluster. So I won't go through those steps. Make sure to deploy the ingress controllers with the Prometheus exporter enabled. Once you have this, you make sure to collect the IP address because we will need it to expose the hipster shop out of a cluster. Once we have the new IP address and the various ingress rules will be updated, so we will need to update those two files. One is the hipster shop deployment file. The other one is the K6 load test. And now, because we are going to try to create a scaled object based on metrics stored in Dynatrace, we need a Dynatrace tenant. So if you don't have any Dynatrace tenant, no worries. Go to dynatrace.com and there is a free trial link here. And if you go to the free trial, you can basically put your email, and in few few hours, you will get a Dynatrace tenant. So here I already have my tenant. Then there are a few requirements related to Dynatrace. So let's jump into this tenant. The first thing is within your cluster, you need to make sure that the Dynatrace is monitoring it. So it collects data out of your cluster. To do that, you will have to click on deploy on the left menu of Dynatrace. And this is where you're going to install the one agent. And you just have to follow the instructions. So start installation, and you will have, in our case, if you use OpenShift, you can still use OpenShift if you want. In my case, I'm using a traditional Kubernetes cluster. It's in GKE, by the way, but you will see it's still a standard Kubernetes cluster. So make sure to put a name. You don't need necessarily to put a group. You can leave the default group. And you can create 2 tokens. So just click on those 2 buttons. It will generate the right tokens expected. Because it's a demo environment tutorial. We don't have any SSL, so you can skip the SSL check. And if you use GKE or any others of those layers, make sure to enable this one as well. And once you have this, you will have to download. Once you have put a name, you will download the Dynacube, which is the configuration file for our cluster. And you will be able to obviously download the Dynacube. And once you have the Dynacube, you just have to apply the following instructions to deploy Dynatrace in your cluster. So once you have done this, 2 things you have to do. So once you are in your cluster, make sure that if you use kubectl, you will find few things. So first, you will need to have the operator deployed, the webhook, obviously, and the ActiveGate. But there are 2 things here. You can see that the ActiveGate is here, and then you have a couple of cluster 1 agents. So here I've deployed Dynatrace to monitor the nodes, but also the apps. So that's why you have one cluster agent, I would say, per node, because it's the daemon set deployment. So this is what you're going to expect if everything has been deployed properly, and it needs to be running, of course. And in fact, to control that everything is running, you can see deployment status, and you will see where it is, or simply after a few minutes, you simply have to go to infrastructure, Kubernetes, and you will see your Kubernetes cluster, which is here in my case, and you will see the various namespace, and everything will be normally populated with the events, the metrics, and so on. So that's for the first thing. You need that. Then we are going, obviously, to collect metrics from the API, and I'm going to use the K6 integration. So I need an access token. So click on the left menu on access token. Click on generate token here. Put a name, of course, test, for example, whatever you want. And there are 2 scope from the token that we need. So it's metrics, so type metrics. And we are going to ingest metrics with the K6 integration. So we need that right. And Keda, to be able to use the metric API scaler, needs to interact with our API, and it needs to read metrics. So those are the 2 rights that you need. You can create the token, and then you will have a token displayed. Make sure to copy that value because we need to deploy it. And last, make sure to copy the first piece of the URL. So https:// the Dynatrace URL. So id-live.dynatrace in your case, because here I'm using a dev tenant. So that's for the Dynatrace requirement. So make sure to have the token and the operator, the Dynatrace operator deployed. You will need it for the rest of our tutorial. So copy this token value in the token variable, copy the host information in the Dynatrace host variable, and then we will replace all the various files that is required, that will be required for the rest of the tutorial. 2 last steps before we go to the next official steps of our tutorial. You will have to add some annotation dynatrace annotations to the Nginx deployment to ask dynatrace to scrap the Prometheus metrics produced by Nginx. So make sure to edit that deployment and add those annotations because it will help dynatrace to get it. So I can show you briefly what the results that you will need. Here it is. So if I do an edit, so we're not going to do an edit, but make sure to place the annotations in the template sections and not in the previous steps. So here you can see that I have the Prometheus dynatrace annotations already in place. So I'm ready to go, and dynatrace will pick up the metrics produced automatically by this exporter. Last, make sure to deploy, of course, Hipster Shop. There is one small load test running, and then we will apply a extra load test. So this first load test is just there to make some minimal traffic, and then on top of that we have a real load test that generates some stress. All right, so next step of our tutorial is to deploy Keda. So let's bring the terminal here, and we are going to add those Helm charts. So first, add the official Keda Helm chart. Let's do an update, and we're going to create a Keda namespace. And finally, deploy Keda within this namespace. All right, so now let's have a look at the pods in the Keda namespace. So we can see that we have the operator that will manage, as expected, our various HPA and everything based on the scale objects. And close to it, we have the Keda operator metric. So that will be the metric API, the adapter connected. So first, let's have a look at the metrics that is coming in Dynatrace. So let's jump into Dynatrace. So there is already a test running in this tenant with a couple of few users. So if you want to see the traffic obviously goes through the front end. So we will have most of the traffic directly in the front end service of that we can see here in Dynatrace. So we can look at the dynamic request of the traffic, look at the traces and so on. But if we wanted, we can do create an analysis view, combining few metrics from this particular service, and then create a metrics out of that. That could be used for our Keda use case. Again, that could be a solution. In my particular case, I wanted to do the similar steps that we did with the previous tutorial using just traditional HPA, is with Nginx. As you remember, we added the annotations on the Nginx, which means I'm getting some Nginx metrics coming in Dynatrace. So let's have a look at those metrics. So all the metrics coming in from a ingest perspective will be available in metrics or data explorer. So let's jump into the data explorer. There are two types of things, metrics coming in, the K6 integration. So if I type K6, I can see that we have all the data related to load test, but I'm not going to use data from a load test to scale my workload. I want to use Nginx. So I'm going to type Nginx, and I should see all the data coming from that exporter. And I'm looking for a metric related to the request here, request count. So we're going to do something about the number of requests per second coming in that service. So now we can see that we have up auto, let's put average. So we have about 71 requests per second, and we can split, if I wanted, to by service. So service will be who is serving that traffic. In our case, we have only one ingress, so obviously it's only the front end. So now we have the right query here, but we don't want to split in our case because it's going to be a scaled, it's rule for the front end service. So let's remove the split and put instead here the filter based on the service. I'm going to say service, front end, and we're going to run the query. So we have the average. So we have everything. So we had 100 something an average on this particular service, and it's going up here. You can see we're going up to 300. So I'm going to take that code here, which is the metric API. So I'm going to copy that particular request. And then I have the ability to test my API calls, because at the end, the metric API will basically do an API call to Dynatrace. So I'm going to click here in the right top corner, and we will have here environment API v2. So I'm going to go on environment API v2. That gives you the API explorer of the Dynatrace API. And I'm looking for the metrics one. So here is the sections for the metrics. And we want to get some metrics. So here we can query. So we can do a query, get data points. This is what I'm going to do. I'm going to do a query out of this. And here, of course, you will have to authenticate this token here. So I'm going to authenticate to this API. So I'm going to, here, this is where you're going to also place your the value of your token. So I'm going to authorize the API. So once you have authenticated the API Explorer, we can test our query. So we're going to put here I'm going to click on try it out here, and I'm going to put my query here. And let's put the last 3 minutes. So minus 3M, that's fine. And let's run that query. So here we have results coming in, so 200. And we can see that we have a payload available, so we can look at it. But as we can see, it's there is a JSON object with results. This is where we're going to grab the metrics. And within the results, it's very important that we get that path, because we're going to reconstruct this JSON path. We want to get to the values, which is here. So results.data, and it's a table. So results number, it's a table. So results number, the first one. Then data, the first one, because there's only one. And then we dot the values, and we can grab the first one as a reference, as an example. So it will be results dot 0, the first results, data, the first data, and then value and the first value. So that's the query. So let's copy that you have here the curl command that's been executed. So you can copy the entire query, just the URL, because we will use it in our definition of a scaled object. So let's have a look at the scaled object. In the repo, I have the file here. So of course you will have to, we will need create a trigger object. So we already created a secrets with the Dynatrace API token information. So here I'm creating the trigger authentication object that will be referred in the scaled object. Then I'm creating the scale object where I will start with minimal 2 replica count, max 14. And then in case of there is a fallback, so problem with the scaler, I would go back to 6 replica. For the scale target reference, so you can, I don't have to, if I'm referring to a deployment, I don't have to refer to the API version and the kind. This is going to be default on deployment. If you're using another object, of course, make sure to add the kind in the API, because otherwise you won't be able to match the right object. So here I'm putting the target value 300, because we were seeing that we were about, I think we were about at 120, we are at 123. And we're going to add a new load test. So I'm probably going to reach out, let's put 250, 200. So then at least we will be able to reach the target that we're looking for. You will have, of course, to put, replace the URL here. And this is the exact query that I did. I copy pasted. And the value location is like explain results 0, data 0, value 0. So that's going to be the first element of each one. So let's apply this one. available. So I'm going to do kubectl. All right, the triggered authentication is created and the scaled object is being created. So now it seems all right. What we're going to do now next is apply a load test. And this load test is going to add 200 extra users there. So to apply the load test is going to be kubectl. If you look at the pods running in the HipsterShop namespace, that we have two tests running at the moment. The one with the small load and the one the other. And you can see here that front end has already increased. So we have now 4 replica available. So that's interesting. Let's have a look at what we get. So first we are at the cluster level. So we can see that we have a couple of information. We have here a couple of events. You can see that we have events Keda scaler started and scaling replica set. So you can see that we already have some events already at the cluster level. And we also have TriggerAuthentification added. So all the events that we listed in our course or our explanation is there. So at least we have more information than in the traditional HPA. Now let's have a look at the namespace HipsterShop where everything is happening. And now same thing. If I go here, we can see that scale replica set is done. The similar events is there. So basically just by looking at the events, I already understand what's going on. Then it's on our front end workload. So let's have a look at the front end service or deployment. And we can see that I currently have in total 4 replica, and we have some errors. The logs has been populated, but as you can see here, we have scaling. So we have even on the pod, we see that we scaled the replica directly at certain state. So we have the information about it. We need to create a rule to get the metrics from the Keda. So if you do get the pods from Keda, we have the API server and the default port that we saw. It was the 9022. So let's do kubectl. All right, the port has been forwarded. Now let's have a look at the local host 9022 and metrics. As you can see now, we have some values. So we have the metric adapter value. You can see that it's getting the value from our specific HipsterShop scale object. We have the value 639. So that's how it's been increased. Okay, so how do we add those Prometheus metrics from Keda? So to do that, I'm going to, we did a port forward, so we have the metrics available still there, so we can still have a look at them. What we're going to do is look at what we have here. So let's do get deployments to see if we need to add those annotations to our Keda operator metric API server to let Dynatrace scrap those metrics. That could be an option to do it from the deployment there directly, which we did for Nginx. If I don't want to, I can still create a virtual service. So I will have to grab the right label selector from the deployment. So then I can create a service that will map to the pods running from this metric API server and add in that service, in that case, the right annotations. But in our case, let's edit this deployment to simply. So I'm going to do edit. Here it is. And similar to the Nginx, in fact, I'm copying the annotations from Nginx, so we're going to update it. So I'm going to go to the template sections, and I'm going to add in the template sections. Here, there's only labels, but we are going to add annotations. All right, and then I'm just going to simply paste those annotations and update it with the one with Keda. So it's 9022. So once I've done this, which is everything is fine here, metrics and everything, this is what we had. And I just simply have to update this one, and then it should restart our pod. So it's going to start in a few seconds, adding the annotations, which means once the annotation has been added and running in few couple of, I would say, minutes, I will be able to see the metrics coming in the entries. So if I search for Keda like this, I will see the metrics. So here I already have some metrics coming in. You can see we have the metric adapter scalar error total and the scalar value. So we can hear it. We still probably have more data points required because it's just freshly being created. So let's, oh, here it's still, with still more data point to come. Here we have one data point as of now. So it's reporting basically the current value. So 653, that's the value provided by the API from a data entries perspective. And then here I have a couple of extra information, but like I said, we need to wait a bit to have more information. Here we have more metrics, more points. So we probably have more. We also have the various dimensions available as well in a few seconds. So it's still not there yet, but in a few seconds again, we just created there. So at the end, Keda, with the help of the events and with the help of the metrics, we can follow our scaling process. So it's very positive and very good news compared to what we experienced with the other episode related to HPA and VBA.
That's it for today's episode related to Keda. Keda, as you can see, resolve all the challenges that we faced using HPA. So like I mentioned, the fact that if you're using HPA with traditional resource metrics is fairly easy, but usually the rules are quite simple and weak. So it makes more sense to start using custom metrics. And if you want to use HPA with custom metrics, this is where the fun game starts, with the metric server, the right metric adapter, configuring the metric adapter, and so on. So as you can see, it's a very complicated journey. The other disadvantage is the fact that HPA doesn't provide us much details on how we could observe it. And the great news, I think Keda, with all the various CRDs and features, help us to manage the auto-scaling with tons of different data source, provides metrics and events. So at the end, Keda, if you're looking for a solution to easily scale your deployments or any other objects, then Keda will basically make your life easier in general. If you enjoyed today's content, don't forget to like and subscribe to the channel. So see you soon for another episode. See you. Bye.